So today I will talk about addition of vectors. So vector addition is not similar to the scalar addition, right? Vector addition is not similar to scalar addition. There are some laws. There are some laws which govern vector addition, and these are known as laws of vector addition, and these laws are known as laws of vector addition. So there are some laws. So first of all, let me talk about parallelogram law of vector addition. Parallelogram law of vector addition. So suppose we are given two vectors. So one vector is this, and say there is another vector, and let us say these two vectors will represent two sides of a parallelogram. Say this is one side and say this is the another side. Then if we form a parallelogram using these two vectors, then the diagonal is the resultant of these two vectors, that is, this R is basically A plus B. So this is the law of parallelogram law of vector addition. So in words, what I can say that according to this law, sum or a resultant of two vectors A and B is the diagonal of the parallelogram, of which A and B are two adjacent sides. Thus, this is basically mathematical representation of parallelogram law of vector addition, where A and B represents the two sides of a parallelogram, adjacent sides, and this is the resultant, right? Next is very important, that is known as triangle law of vector addition. It's triangle law of vector addition. It's a triangle law of vector addition so let A and B be two vectors. Let A and B be two vectors, and if these two vectors form two sides of a triangle, taken in same order, taken in same order, then their resultant, is the third side of triangle, side of a triangle taken in opposite order, taken in opposite order. And let me explain it. And first of all, let me talk about what is the meaning of taken in same order. Taken of same order means when, say, consider a vector A and say there is another vector B. Now let me redraw these two. A vector, when we brought another B vector in such that its tail touches the head of this vector A, then that's the meaning they are taken in same order. Means it's this way, right? Now the resultant will be the third vector, and what it is taken in opposite order, because A and B are taken along this way, means they are along this direction, and third vector is just opposite to it. Then this is the resultant and it is A plus B. That's the meaning of it. Means its order will be taken in opposite direction. So this is the triangle law of vector addition. We can also take it otherwise also. There is another way to look at it. So say this is B vector is drawn like this and A vector is drawn like this, then the resultant will be this one. So now see, this resultant and these both are identical, so from this diagram this can be written as B plus A. So if we club these two, then I can say that A plus B is equal to B plus A. So that means vector addition is commutative in nature. Vector addition is commutative. Vector addition is commutative. Now in the last I will talk about Polygonal law of vector addition. Last one is the Polygonal law of vector addition. Polygonal law of vector addition. So if we have more than two vectors, if we have more than two vectors, we have more than two vectors taken in same order, taken in same order, form sides of a polygon, then their resultant is the closing side of the polygon but taken in opposite order. But taken in means this closing side is taken in opposite order, right? So for example, let us assume that I have given a vector. Say there is a vector A there's a vector B, and there is a vector C. So if we add these three vectors and they form the sides of a polygon, means one vector is A, another vector is B, say it is B vector, and say it is C vector, and the third vector is C is taken in this way, then the closing side, this is the resultant. So that means this R is equal to A plus B plus C. So this is the Polygonal law of vector addition. Let us take one more diagram. To understand it, say this is A vector, this is B vector, this is C vector, and say there is D vector. So it is A, B, C and D, and let me draw a polygon using these three vectors. So there is A vector, this is B vector, this is C vector, and this is D vector. Let me do one thing. Yeah, let me take these little bit different. This is C vector, and this is D vector. So it's like this. This is B vector, this is C vector, and say it is D vector, it is B vector, it is A vector. Then the resultant will be this one. What it is taken is opposite to this. So this is the resultant. So here R is equal to A plus B plus C plus D. So this is all about the Polygonal law of vector addition. Even we can prove it by also using the triangle of vector addition. Say if I use a triangle of vector addition here using this, then this vector is known as say C prime. So this C prime is equal to A plus B. Now if I take this triangle, this part, then this R is equal to C prime plus C vector, and C prime is A plus B. C will remain as it is, right? So this is a way. So that means triangle law of vector addition is the main law of vector addition. Using that we can derive parallelogram law of vector addition and even this polygon law of vector addition. So this is all about the vector addition.